So in the previous video we were talking about differentiation. Just like every charge have an opposite charge of it, at the same time the differentiation also have an opposite process at the same time, and that process is called integration. So if you remember the last video, you might also remember that differentiation is basically the rate of change of a function for the smallest change in the variable it depends upon. Now, if we already know the differentiation of a function and we just reverse that process for a certain change in the variable, that process is basically called the integration. To make it a little funny, integration have a sign which looks a little bit like a snake without a head and tail. Let us say that the differentiation of a function is 1. Now our job is to find what is the function. The simplest thing that we can do to find a function is to go back to the basics of differentiation and do a little hit and try to get a differentiation of a function which is equal to 1. Then that function will be the integration of 1. Yep. And the other more simple way is to be the Leonhard Euler. Yeah, you need not to be like that, I admit that, but still you need to memorize it a little bit. Now what you can do is to imagine the case of a function which have a differentiation which is equal to x. Now you can again go back to the basics of differentiation and do a little hit and try and use a little bit of your logic. You will remember, or you may get a result which is equal to the x squared divided by 2. So if we are smart people, we would give it a little notice that what happened in here, that the power of x is increased by 1, and that power also becomes the denominator of the final result we got. So if we are smart people, what we will do in here, that we will write a general equation instead of going back every time to the basics of differentiation and doing a hit and try, and we will memorize that. Yeah, we will become Leonhard Euler. Yeah. So to do that, let us say that the differentiation of a function is x with a power n. Then the function will be x with a power 1 more than its previous power, and one more thing that will be added to the result is a denominator with the same value as that of the power it have right now. Yeah. So this is the general equation we can use to solve such problems. Yup. You don't believe me? You can test it for different powers of x by going back to the basics of differentiation. And yeah, believe me, it's not dangerous trying at home. And if there is a constant, let us say 1, 2, 3 or 4, I will take a as constant before x with a power n. So to integrate that, we will do a little simple process. What we will do, we will take out a from the equation, and we will do it as we did in the previous case. in the end, we will multiply it with a, and that's the solution. In other cases, when we have a big equation with a number of x with a power n, o, p, and different powers like that, let us say that a times x with a power n plus b times x with a power m plus c times x with a power p. Yeah, it's the alphabet p, not the p. What will we do in this case? Try guessing. Wait for a while. I'm waiting. You are guessing. I'm still waiting. Okay, I'm done. So, it must be a piece of cake if you know how to add. What we will do in here is we will integrate each part of the equation separately, and we will add the result of each of the parts. Yep.
If we have a function with a separate constant in it, we will have no trace of the constant in the differential of that function. So if we integrate that differential, we will add a constant like c in the equation, and we will get the value of that constant using the boundary conditions that we will learn in future.
In the end, I would like to thank you for listening me up to this time.